Hello everybody. Thanks for joining me today as I talk a little bit about virtual commissioning and the ways that it could maybe help with your company and your design process. So hopefully by the end of this you'll have a better sense of what this technology is and you'll understand how it could best be used in your company. So we'll start by talking about commissioning. And this is the phase of the design cycle where everything comes together. It's where the system is integrated. It's sort of the first build. And for many people, there's a lot of costs here, and it's one of the riskiest phases of development. And this is due to the reworking that's going to be necessary, and that's hard to predict. Or trying to go on the other side of that and the costs of over-engineering parts because you're trying to minimize the risks of reworking. If things fail, there's a damage to reputation there as a company who doesn't have a very reliable product that they're delivering. And at the end of the day, it's going to make the time to market a lot less predictable. So these are some of the costs of commissioning. Moving to virtual commissioning, what sits at the base of that is what we call a model-driven digital twin. And these technologies have been used in the aerospace industry and the automotive industry for some time, but we're just starting to see them being more and more adopted in the automation markets. So a digital twin is a virtual representation of a physical system. In this case here, you could take a robot arm. And it's essentially a physics-driven model that is able to simulate all of the mechanics involved and all of the behavioral effects across many, many systems. And some digital twins are used and created in a big data sense. And what that means is the product is shipped. We use a lot of sensor data to provide a model. But from our perspective for virtual commissioning, we use a model-driven digital twin. So this comes first. So we've got this model, and then we are enabling the virtual commissioning process, which is machine-level integration testing using this model-driven digital twin. And what this allows you to do is to perform some of the commissioning tasks, many of them really, to perform some functional verification using an accurate model-driven digital twin instead of waiting until the commissioning time, the physical commissioning, to spot those errors. So it's a much lower cost way to spot many of the errors that might come up, and it can really be a lot more than that. And now how does this work for different companies? Well, for some folks this will be very useful. For some folks it may not be useful at all. But as the automation industry increases in its complexity and its just need to be more competitive, these traditionally automotive and aerospace developments are now moving over to this sector. How it works in a little more detail is to start with a concept of the product that you're going to deliver, and that'll be the basis of the model-driven digital twin. So that'll be created many times from your CAD model data that already exists, but it can be created also from scratch, whatever works best. The controls team will be doing some control development for the development needs. And then when this starts to come together, this is this hardware validation moment where we've got the model in hand, we've got some controls, and we're going to be testing the controls themselves, not on a physical prototype that we've built in a costly way, but in the accurate to reality model that we've created. So that can help iron out, some studies have said up to 75% of the software bugs that can sometimes be there. Now it can be more than just virtual commissioning. This model-driven digital twin is sort of like the ultimate guidebook for a product. And what that means is there's a lot of different kinds of benefits that twin can unlock. So going forward into the operation of that piece of equipment, there's a lot of ways that diagnostics can be improved, that the operator usage can be improved, and we'll get to that later, but it's a really powerful tool that for most people is primarily very useful for the virtual commissioning process. And to show it in just a graphical way, on the right there we've got our model, our digital twin. Using this increasingly popular standard called the functional mockup interface, that's how we bring that model into popular automation software. And when we can bring that model inside, now we're able to bring everything together in one piece of software to do that kind of testing. So that's really been a key technology that's been responsible for the growth of virtual commissioning. Now, is it for you? Well, it often is going to be able to be useful for a variety of people in the automation industry. And this is because it can help out with new product designs. It can help you stabilize your time to market. So that's very useful when quoting a customer. If you've got certain kind of load requirements that are going to have, say, quick returns, and they're going to have some more complicated loading patterns, then what that means is having a physics-based understanding of that on the outset, and not just effective inertia tables, but a really highly accurate behavior over the entire dynamic range. That'll allow you to engineer those parts much better. So all of this means you'll be more competitive with the products you make. You'll be able to assure your customers that, say, the mean time to failure of a certain piece could be a model-based number that you have, not just a sense of intuition or what has worked in the past. So there's a lot of benefits here, and this is why it can appeal to a lot of folks in this market. So I'll go through a couple very rough sort of personas of an engineer, and maybe you might find bits of yourself in each of these. And we'll talk about how these could fit, how virtual commissioning could help out with these folks. So the tweak and build engineer, this would be an engineer that is typically making small design changes, and those changes come from their experience and their intuition. So they're not doing a lot of computer-aided engineering on a physics-based level here. They essentially know what they're building next. This means that they may not be doing designs from the ground up, and they may not need a full-featured model-driven digital twin. But if they were to take on some of these technologies, even to have certain parts of their new designs being modeled, they'll probably be able to increase the reliability and lifespan of these products. So maybe they're making new products, but it's the mean times of failure that is what's getting them, and it's hard to diagnose how it is certain things come to fail. They might be able to benefit from learning more about that. If they are trying to cater to a wider range of customer needs, this will really allow engineers to have a confidence when they move beyond their intuitions to really meet the increasingly competitive market here. And this will lower the risk of developing those new products. So these engineers may be in a comfort zone now, but as this market continues to evolve, at some point the demands placed on folks in this industry are really going to be increasing. If we talk about the new design engineer, this would be someone who has a longer design cycle to work with, and they're typically taking on newer products with a lot more changes and all the risk that kind of comes along with that. These folks are really the ideal candidate for virtual commissioning. And it's not to say that other folks can't get value from it as well, but these are the folks that are going to really understand how this can help them out along so many parts of their design. So this is going to significantly lower the risk that they probably already know they have to take on in developing new products. It's going to result in a more reliable time to market, and that's going to be a great help for just meeting the contracts that they have with customers. So that's going to be a big help. So there's a lot of different ways that the new design engineer is going to benefit from this, and it's something that we've seen a lot of success with. Of course, there's really some ramp-up time in learning how to use these new technologies, but we'll get to that later, because to take something like this on, there's a lot of techniques out there to really smooth that out and to make it a very quick process. So the sales team, surprisingly, can also really benefit from this. And the reason is really because there's a variety of customer requirements that they really need to be able to understand and address, and to qualify the needs of a customer and promise the right kind of products. Oftentimes they'll have to consult with the engineers, but some of those times aren't as necessary as they might be. They may end up just bottlenecking the engineer's time. And what that means really is using the model-driven digital twin in the virtual commissioning process. they can spin out smaller apps that will be model-based qualification tools. So let's say you needed to understand. A customer comes to you and they're asking for a certain kind of delivery mechanism, and there's some motors involved there, and their loads are going to be a certain size. You just may not be sure if the kinds of motors that you use could fit what they need. There can be quick apps that would be able to you plug in those values that you need and provide the customer with a real sense of assurance that you're going to be able to have success with this product. And that's a whole process that happened without needing to take the engineer's time, who are probably developing new products. So there'll be a lot of confidence there, and it works for the sales team. It's a great way to give them some more autonomy and let them move their sales processes faster. Lastly, for management, of course, they're not interacting with these tools individually. On a high level, they just want the company to succeed, and they want to take a long-term view on how much risk they want to take on in new innovations, because they need to stay competitive, but without taking on too much risk. And this is really at the heart of what the virtual commissioning process is. It really helps trade in some extra time up front for modeling and for analysis, with a significantly less variable time to market. So it can really cut out a lot of risks with a bit more time up front. And again, this is what the aerospace industry does all the time. They've recognized that more time up front reliably makes things more on track down the line. So that'll help manage that risk better. They'll be able to test out new designs, so the proof of concept kind of iterative work can happen a lot faster, because you can just start moving through different examples of motors, or you can change variables and quickly run simulations to see if your hydraulics are in order, or a variety of other questions you may want to ask. So that all comes together with giving them just a much better ability to lay out roadmaps and to promise new developments in where they want to take the company. So maybe you saw some yourself in some of those personas. Certainly we think that in the automation industry, there can be a way that this technology can help out many people. And if not specifically for the virtual commissioning process, just having a model-driven digital twin is a hugely effective tool for a variety of reasons. I'll go through a couple of those now, because it really is a powerful digital tool to have, and the adoption of it seems to be increasing over the years. So at an early stage, like we talked about, it's conceptual development. So you can experiment with all of the parameters and variables of your design to understand how loading affects the electrical systems, how the hydraulics are going to affect the thermal behavior on certain parts. So having that system level, that multi-domain insight, it's huge for developing concepts quickly. You don't have to go back and take weeks to just tweak a few things and run a full simulation here. The simulations are quick, and it really keeps that momentum up in engineering teams. We hear that a lot. Moving to sort of on the operations side, these things are great for online diagnostics. And that means that if you have a digital twin that understands how this product should be operating, when you run that in parallel against the sensors that are in your physical product, you can actually see that drift from the first ship performance, from the ideal performance. And what that's going to do is allow you to see those deviations and take note of them a lot sooner than you might otherwise. Because even if they're minor, you'll be able to buck those things quicker. You'll be able to figure out what those root causes are. Because on a digital twin side, there's a lot more information to be gleaned from knowing that perhaps the delivery of a load is slowing down. And that could be for a variety of reasons, but from a digital twin perspective, it can help you narrow those root causes in a much more effective way. And then if you wanted to keep the operation of this device going for a while until you were to do those repairs, you can just tweak a few variables in your digital twin to understand how to achieve the desired motion path given the non-idealities of the product, you can feed those back into the main products. You can keep them alive for longer. From a sensors level, sensors are expensive, and if you had a model that knew on a physics-based level, if we apply this much electricity, this much power to a certain motor, and the torques are spinning out in a certain way, what will the motion of a certain area be, or what will the inertias that are experienced at this point be? For many folks, this means buying sensors and installing sensors in a variety of locations. But a physics-based model already has that information because it already has the full system of equations for what's going on in this whole system. So you can replace faulty sensors temporarily. You could even replace them for the long term if you don't need that physical information for anything else. This allows you to add more inputs for your controllers. So when doing control design, you'll be able to add a lot more places that you want to take those inputs with far fewer costs involved. Kind of spinning off the online diagnostics section, benefit here is predictive maintenance. And this allows you to determine component lifespan using a digital twin to predict maintenance schedules with a greater accuracy than before. And this is really useful. Say you were noticing that drift from the ideal performance, and you made some tweaks just to buy yourself some more time, but now you've known that the issue is identified, and you're going to be able to spot when you should fix these things before having to actually see that downtime happen. So it can really tighten up maintenance schedules. And we've worked with a lot of companies here at Maplesoft that are specifically trying to do just this. They want to make sure that they're replacing things right on time, not too soon to waste lifespan on a part, but also they don't want downtime. So you can really get your margins a lot more accurate with a model-driven digital twin. And overall, when we say product enrichment, I'm really talking about giving your end customers a better product, because there might be a digital twin enabled feature in here that's going to offer new benefits. And we know this may not appeal to everybody, but there's a real benefit to those who are looking for a better product where operators can have much better control over it. So the operators themselves might be able to see better diagnostics information, and that's going to allow them to make those adjustments if they need to. And you can do this all in a very easy to use manner, because you can essentially skin the digital twin interface for only what's required to ship. So you'll be giving your operators just a much greater way to have an impact on the machine. Or they could even train, this happens in aerospace sometimes, they'll be training to use a certain machine, but they don't want to have the risks of damage to that machine during training. So using a model-driven digital twin, they can train how to interact with it without having to actually put the real machine at risk. So those are some ways that the digital twin can be hugely important to add to the automation industry and the virtual commissioning story at large. So to wrap up with a bit about us, here at Maplesoft, we've been in this work, and we've got over 30 years of modeling and computation experience. And we've worked with a lot of folks in the automation industry and far outside of that. And really what we're trying to do now is to make these services and these technologies a lot more accessible to the automation market. We see a huge need there, and what that means is we have a set of dedicated staff here that are whose sole job it is to really make the transition as smooth as possible. So if this is a technology that you're looking to bring on board, but you're concerned about, say, the ramp-up time or creating the initial digital twin, we offer all sorts of expertise to help with that process through tools to help you size components. We've got customized training courses and contract staff. So we've got a suite of services here to help you make this a reality. And with that, I'm going to thank you for your time. And if you have any other questions, don't hesitate to visit our website at maplesoft.com, and we'll be sure to be in touch. Thanks so much, folks.